we are going to figure out if there's a cycle in the linked list. So if we create our linked list the way that we have been creating, we will actually never get a cycle, because there's only two functions over here. One is the append to the head and one is append to the tail, right? So there's an append and append to the tail. All it does is appends in the head, or adds in the tail. But let's say for some reason, somehow there is there, let's say this was the linked list, so 1 goes to 2, 2 goes to 3, 4, 5, 6 and 7, and somehow 7 actually started pointing to 3. So there is a cycle in this case. So what we will do is, how to find if there's a cycle, what we'll do is we'll actually first check if the head is null. If the head is null, then there's nothing, like there's no cycle. Otherwise, what we'll do is we'll actually keep two pointers. One pointer is a head, is a front, front, and one is a back. Right? Both of them will actually start pointing over here. So there'll be a front node and there'll be a back node over here. So front and back, both of them will be there. Next, what we'll do is, let's say there was no cycle. Let's say there was no cycle. So 7 was actually pointing to null. So in this case, what will happen is, first what we'll do is we'll move the front by 2 and we'll move the back by 2, back by 1. So front will be moved by 2, so front comes over here, back comes to 2. So front comes here, back comes here. Then front will move by 2, so front comes here, back comes here. Right, so back comes here. Then front will move by 2, so front comes here and back comes here, back. And then after that, front tries to move by 2. It cannot actually move by 2. So what will happen is that it will just break out. So if there is no loop, then front will actually reach null. Okay, so that's the first case. Let's say if there was a cycle. So if there was a cycle, so 1, 2, 3, 4, 5, 6, 7, and let's say 7 was pointing to 3. Right, so we'll have front and back. So front will move by 2, back will move by 1, so back comes here. Front will move by 2, so front comes here, and back will move by 1, so back comes here. Front will move by 2, so front comes at 7. Back will move by 1, so back comes over at 4. Right, so back is at 4. Next, what will happen is front will move by 2, so front will move by 2, so front comes over here, and back is moved by 1, so back comes over here. Then front will move by 2, so front comes over here, and back will move by 1, so back comes over here. So they will meet at one point. The first time, like when they meet, that was actually not the meet. The like front actually had moved, but back had to move also. But they will actually meet at 6, and they will definitely meet. We'll actually do the theoretical proof of that later on, but they will definitely meet. So if the front and the back, both of them meet at a certain point, then that means that there is a cycle, right? So that is basically the code that we have to write. Okay, so we will come over here, and what we'll do is we'll say create cycle. So we'll have a private function, void, which will say create cycle. So we'll create a cyclic list, right? So we'll say append, and actually create cycle we'll create in the main. So let's say public static void create cyclic list. Okay, we'll actually have a linked list. Let's say linked list of integer. Right, that. So we'll say node. So we'll say list dot append, and we'll append 1. So we'll do 1, 2, 3, 4, 5, 6, 7. Same list that we decided. So 1, and then 2, 3, 4, 5, 6, 7, and this is append tail. Right. 1, 2, 3, 4, 5, 6, and 7. Next, what we'll do is we'll get to the head, uh, and then we'll say list dot head, list dot head dot this dot head is 1, dot next will be 2, dot next would be 3, dot next would be 4, dot next would be 5, dot next would be 6, dot next would be 7, will be equal to dot next is 7, and 7's next is equal to, it was pointing to null, it should point to 3. So 3 is list dot head dot so list dot head is 1, 1's next is 2, and its next is 3, right? So that will basically create a cycle in this. We'll come over here, we'll create this list, we'll delete all of that, and then we'll say create cyclic list, and we'll pass the list over here, right? And what we'll do is and we'll just put a breakpoint over here just to see what happens. So we'll debug this, and we have the list which actually has 1, which points to 2, which points to 3, points to 4, 5, 6, and 7, and 7's next is basically pointing back to 3. So we actually have created a cycle, right? So we created a cycle, and then in the linked list over here we'll actually figure out if there is a cycle, right? So we'll say public boolean, and we'll say is cyclic. Okay, first thing we'll check is if head is null. If head is null, there's no cycle, we just return false. Otherwise, what we do is we actually take 2 pointers. We'll say node t, and we'll say back is equal to head, and we'll take the front. Front is also head, right? So we have a back, which is head. Back is head, and front is not head. So next, what we'll do is we'll say while front is not equal to back. While front is not equal to back, what do we do? What we do is we actually move front by 2 and back by 1. So we'll front by 2. What we can do is we'll say front is equal to front dot next. So we'll say front is equal to front dot next, and back is equal to back dot next. Okay. So we are moving the front by 2, dot next, and back. So over here we need to check a condition. Let's say if there's no cycle exists. So if there's no cycle exists, then what will happen is we have to check if front dot next is equal to null. If front dot next is equal to null, or front dot next is equal to null. Actually, I think the condition should be front command X. If front dot next, if front is not equal to null, and front dot next is also not equal to null. If front is not equal to null and front dot next is not equal to null, which means that we can actually move the front by 2 times and back by 2 times. If not, then either front is null or front dot next is null. In both of these conditions, we return false, which means that there is no cycle. Okay. While front is not equal to back, we will actually continue to do this. If front becomes equal to back, we actually break out of this loop and we return true. I think that should do it. So we'll come over here We created a cycle, and we'll say list dot is cyclic. So we should actually be printing true. So we'll run this, and we are actually printing true. Let's actually break the cycle. So we will not do this, and we'll run this, and it should return false. Oh, it's returning true too. Oh, why is it returning true? While front is not equal to back, front dot next is equal to null. Front is equal to front dot next, back is equal to back dot next. Oh, null. Let's put a breakpoint over here. Let's actually debug what is happening. I think it should be good, but like I don't know why it is. We will actually put a breakpoint in the link list over here. It is actually coming over here. It's just coming back from this one to the next one. Okay. So what we'll do is we'll say while front is not equal to null. While front is not equal to null. While front is not equal to null, and if we reach over here, we'll say if front is equal to back. In that case, we return is equal to back. We return true. Okay, so I think like our previous code was actually wrong. So we'll come over here, we will do this, and this should return as true. This is returning as true. We'll comment this part, and we'll say we'll run this, and this should return as false, which is actually correct. Let's actually make it for the even and odd kind of thing. So that was let's actually try this out. This should also return as false. Why is this happening? So we'll come over here, do like this. Oh yeah. We'll actually return. This should be false. Okay, that'll do it. So that is good. We'll come over here. We'll try the odd one, and that is returning false too. We'll create a cycle, and that should return as true. Okay, that's good.